4.2 Lesson 3, Derivative of a product of three or more functions. In the previous lessons, we used the product rule to find the derivative of a function that is the product of two differentiable functions. How can we extend that to a function that is the product of three or maybe even four differentiable functions? And then we'll take a look at a couple of examples. So those are our objectives. You will know how the product rule extends to finding derivatives of functions that are products of three or more differentiable functions, and then you'll be able to find the derivative of a function that is a product of three or more differentiable functions. And of course, we're learning about the product rule, and as you saw in yesterday's lesson, sometimes in addition to the product rule, you may also need to apply the chain rule. And of course, there are a number of differentiation rules that you have to remember, such as the derivative of natural log is 1 over the argument, the derivative of sine is cosine, the derivative of cosine is negative sine, the power rule, etc. This is the product rule. If you have y is equal to a product of two differentiable functions of x, then the derivative of y is the derivative of the first function times the second plus the first function times the derivative of the second. The question is, what if you have a product of three differentiable functions of x? So we'd like to consider a function y that is a product of three differentiable functions f, g, and h. How do we find y prime? Here's how we can connect what we know, which is the product rule for finding the derivative of a product of two differentiable functions, to get what we need to be able to find the derivative of a product of three differentiable functions. You're going to use the associative property of multiplication to rewrite y as, in brackets, f of x times g of x, and then multiply that by h of x. So in a sense, you're treating the product of f and g as one function and h as the second function. And now you're looking at this as a product of two differentiable functions, so you can apply the product rule that we've been using to find the derivative of this product. So y prime, using the product rule that we've been using, would be the derivative of the first function times the second plus the first function times the derivative of the second. And of course, what you have here is a product of two functions f and g. So how do you find the derivative of this product? You use the product rule that we learned yesterday. So you're going to have the derivative of the first function times the second plus the first function times the derivative of the second. And then you're going to multiply that by h of x. And then you have this plus sign, and then you have f of x times g of x multiplied by the derivative with respect to x of h of x, which is h prime of x. So the last thing that you need to do is just distribute this h of x to each of these two terms in the red brackets, and that would give us y prime is equal to f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. So this is how you find the derivative of a function that is a product of three differentiable functions f, g, and h. If I were to say it verbally, it would be the derivative of the first function times the second and the third functions plus the first function times the derivative of the second function times the third function plus the first function times the second function times the derivative of the third function. And of course, the easy way to remember that is, in the original function, you have the product f of x times g of x times h of x. And in this differentiation rule for finding y prime, you have three terms. And in the first term, you take the derivative of the first function, multiply by the second and the third functions. In the second term, you take the derivative of the second function, multiply by the first and the third functions. And in the third term, you take the derivative of the third function and multiply by the first and the second functions. In fact, this general pattern that perhaps you are observing is going to extend to even finding the derivative of a product of four differentiable functions. And if you wanted to prove this, you can use what we know about the derivative of a product of three differentiable functions and just consider something, do something like what you just saw me do in the last 3 or 4 minutes. You would begin with y is equal to f of x times g of x times h of x, and now you're going to introduce a fourth function, k of x, where f, g, h, and k are differentiable functions of x, and you're going to use the associative property of multiplication to associate the first three functions as, in the product, and then you will see this as a product of two functions, and then apply the product rule that we learned yesterday. And when you do that, the process is similar to what you saw me do in the last 4 or 5 minutes. And when you do that, this is what you will find for the derivative of a product of four differentiable functions. The derivative of a product of four differentiable functions would be, it would have four terms. And in the first term, you'll have the derivative of the first function multiplied by the second, the third, and the fourth. In the second term, you'll have the derivative of the second function multiplied by the first, the third, and the fourth. In the third term, you'll have the derivative of the third function multiplied by the first, the second, and the fourth functions. And in the last term, in the fourth term, you'll have the derivative of the fourth function multiplied by the first, the second, and the third functions. So now we're going to look at two examples. The first one will be finding the derivative of a product of three differentiable functions of x. So we'll be using what we just learned. And then the second example will be finding the derivative of a function of, the derivative of a function that is the product of four differentiable functions of x. We have example 1, y is equal to x cubed times sine to the fifth x times cosine of 2x. So we have a product of three differentiable functions of x, and we're going to use the product rule that we just learned to find the derivative of this function. And of course, you'll recognize that the second and the third functions are compositions of functions. So in addition to applying the product rule that we just learned, within that work, you will also have to use the chain rule when you need to find the derivative of the second and the third functions. So you begin by setting up how you would differentiate. Again, we find the derivative of the first function, multiply by the second and the third. We find the derivative of the second function, multiply by the first and the third. We find the derivative of the third function, multiply by the first and the second. And of course, what you get are three terms, and they're added, as you can see there. So now we'll go ahead and do y prime is equal to the derivative of the first function is 3x squared. Multiply that by sine to the fifth x times cosine of 2x plus, don't forget that plus, and then in the next term you find the derivative of the second function. Let's do it like this. In this line, it's probably good to write it just as I did it. If you want to save a little bit of time when you do the next line, maybe you want to go ahead and write x cubed and cosine of 2x first, and then find the derivative of sine to the fifth x. So you're going to use the chain rule, so you will have to use the power rule first, bring the 5 from the exponent to the front, and you now have sine to the fourth power of x, and then multiply by the derivative of the inside function, which is sine. The derivative of sine is cosine. And probably you want to write this 5 instead of here. You would want to write it at the front. So you have 5x cubed there, and then you have cosine of 2x times sine to the fourth times cosine of x. Now, I want you to notice that here you have cosine of 2x, and here you have cosine of 1x, so you cannot multiply those two factors of cosine because their arguments are different. So I have sine to the fourth x times cosine x. And for the very last term, what are we going to do? Again, I think it's a good idea to write the previous line as I did, but when you actually find the derivative, you may want to do it in a way that perhaps cuts down the amount of writing that you have to do. So I did it one particular way for the previous term. Right now, I think I want to start actually by maybe finding the derivative here. The derivative of cosine is negative sine, and the derivative of the inside function, you have to use the chain rule. The derivative of 2x with respect to x is 2. So what do I get? I get negative sine of 2x times 2, which is, of course, negative 2 times sine of 2x. Negative 2 times sine of 2x. And then I would like to write the x cubed here, and then I'd like to write sine to the fifth x here. And that's pretty much it. That's the derivative. Now, if you want to simplify, you can simplify somewhat. The most common simplification technique, since we have 3 terms, is to look for a common factor that you can factor out from each term. So one thing that you should see is that all 3 terms have x squared as a factor. Here you have x cubed, which you can write as x squared times x. Same here, x cubed is x squared times x. Are there any other common factors? I have cosine of 2x here, and I have cosine of 2x for the second term, but not for the third term, so that's not common. It appears that maybe I have sine to the fifth x here, sine to the fourth x here, and sine to the fifth x here. So it looks like sine to the fourth x is common to all 3 terms. So what I can do if I want to simplify is to factor out x squared and sine to the fourth x from each term. So from the first term, I'd be left with 3 times 1 factor of sine times cosine of 2x. From the second term, I'd be left with 5 times 1 factor of x times cosine of 2x times cosine of x. Maybe I'd like to write the cosine of x first, and then cosine of 2x after that. So I have 5 times x times cosine of x times cosine of 2x, and from the third term I'm left with minus 2 times 1 factor of x, and then I will have 1 factor of sine x. When I factor out sine to the 4th x from sine to the 5th x, I will have 1 factor of sine x. And then I will also have sine of 2x. And that would be my final answer. For our second example, you'll notice that we have a function that is the product of 4 differentiable functions of x. Furthermore, you will see that the second, the third, and the fourth functions are composition of 2 functions. So in addition to the product rule, we'll be using the chain rule to help us find the derivative of this function. And of course, since we have a function that is the product of 4 differentiable functions, to find the derivative, here's what we must do. So we have y prime, and our derivative will have 4 terms. And in the first term, we would find the derivative of the first function, multiply by the second, the third, and the fourth functions. Add to that the second term, in which we will have the derivative of the second function multiplied by the first, the third, and the fourth functions. Add to that the third term, in which we will have the derivative of the third function multiplied by the first, the second, and the fourth functions. And add to that the fourth term, in which we will have the derivative of the fourth function multiplied by the first, the second, and the third functions. The first, the second, and here's the third function multiplied by the derivative of the fourth function. Now that you've set it up, you just have to do it. So you have y prime, and if I'm working here, then the derivative of x squared is 2x, and I write 2x times e to the 5x times sine of 5x times cosine of 4x. And if I'm working with the second term, it's good that I wrote it the way I did in my previous line, but when I'm doing my next line, I may want to write the factors in a different order. For example, I know that the derivative of e to the 5x will be e to the 5x multiplied by the derivative of the inside function 5x, which is 5. So that would give me 5 times e to the 5x. And I'm just going to write 5 times x squared times e to the 5x times sine of 5x times cosine of 4x. And then for my third term, this is the derivative that I need to take. I know that the derivative of sine of 5x will be cosine of 5x multiplied by the derivative of the inside function 5x, which is 5. And so I can write 5 times x squared times e to the 5x times cosine of 5x times cosine of 4x. And when I'm working on the last term, this is the derivative that I need to take. I know the derivative of cosine is negative sine, so I have negative sine of 4x multiplied by the derivative of the inside function, using, of course, the chain rule. So I get negative 4 times sine of 4x, and so plus negative is minus, so I can write minus 4 x squared times e to the 5x times sine of 5x, and this 4, of course, came from the derivative of the inside function, as well as the factor of -1 from the derivative of the outside function, right? The derivative of cosine is negative sine, and the derivative of the inside function 4x is 4. So that's where I get the negative and the 4 from. So the derivative of cosine is negative sine, so I already have the negative out there, so I have sine of 4x. And I already took care of finding the derivative of the inside function. That gave me 4. So I have negative 4x squared e to the 5x sine of 5x times sine of 4x. So that's done. I've actually found my derivative, so I've done the problem. I have differentiated. So if you wanted to, the next step would be to try to simplify by looking for any common factors that you can factor out from each of those terms. And one thing that you'll notice is that all 4 terms have a common factor of x. So you have an x here, you have x squared, so you have 2 factors of x. So all 4 terms have a common factor of x. You will also notice that all 4 terms have a common factor of e to the 5x. So that could also be factored out. And then not all 4 terms have a common factor of sine of 5x. Not all 4 terms have a common factor of cosine of 4x. So what you can do is just factor out an x and e to the 5x from each term. So you can write y prime is equal to x times e to the 5x. From the first term, you'd be left with 2 times sine of 5x times cosine of 4x. From the second term, you'd be left with 5 times 1 factor of x times sine of 5x times cosine of 4x. From the third term, you'd be left with 5 times 1 factor of x times cosine of 5x times cosine of 4x. And from the last term, you'd be left with minus 4 times 1 factor of x times sine of 5x times sine of 4x. So that is the derivative of the function that we had. Y is equal to x squared times e to the 5x times sine of 5x times cosine of 4x. In this lesson, we were able to extend the product rule to find the derivatives of functions that are products of 3 or more differentiable functions, and we saw a couple of examples.